These lectures cover the measures of positions. Our main objective is to learn how to determine the quartiles of a data set. We're also going to learn how to determine the interquartile range of a data set, how to create Box-and-Whisker plots, and also how to find the z-score or the standard score. And we're also going to learn how to find the outline in a data set. So measures of position give us a way to see where certain data point or value falls in a sample or distribution. So a measure can tell us whether a value is about the average or whether it's unusually high or low. Also, the measures of position are used for quantitative data that falls on some numerical scale. Sometimes, again, the measures can be applied to ordinal variables, and those variables that, again, have an order, like first, second, third, fifth, etc. So a quartiles, first we start with the term fractals. Fractals are numbers that partition or divide an ordered data set into equal parts. So quartiles can divide a data set into 4 equal parts. So a quartiles approximately divide an ordered data set into 4 equal parts. Now the first quartile, which is the Q1, is about 1/4 of the data set fall on or below the Q1. Then we have the second quartile, which is Q2. This is about 1/2 of the data fall on or below Q2. This is the same as finding the median. Then the third quartile, which is the Q3, is about 3/4 of the data fall on or below the Q3. So example given here, they say we should find the quartiles. This is a test score of a 15 employees enrolled in a CPR training course, and they are listed below. Here we are going to find the first, second, and third quartiles of the test scores. Now, these are again 15 employee test scores. So first, we put the data in order. That's from the smallest to the largest. For example, when we look at our data here, the smallest value is 5. The biggest value is 37. So we can see 5 up to 37. This is why to find the Q2 is the same as the media. Because in order to find a media, as we said earlier, we have to put our data in order. Then we find the middle value, take the middle value. So here we have we divide the data into 2. Again, we have 15 data sets. So the lower half will be 17. The lower half will be 7. The upper half also will be 7. So 7 plus 7 is again 14 plus the middle, which is again 15. So the middle value 15 will be our Q2. Now, in order to find the Q1, we will go to the lower half. And also to find the Q3, we go to the upper half. The middle value again is our Q2, same as the media. So to find the Q1, we went to the lower half section and we're able to get the middle value, which is 10. Then on the Q3, we go to the upper half. And the upper half section, the middle value is 18. So here we say about 1/4 of the employees score 10 or less. And also about 1/2 score 15 because it's the middle or less. And also about 3/4 score 18 or less. So 18 to the left will be 3/4 of the data set. Next, how do we find the interquartile range? So the interquartile range, again, is the difference between the third and also the first quartiles. So the formula is Q3 minus Q1. Again, to find the quartiles, we put all our data set in order from the smallest to the highest value. Then the middle value will be our Q2. Now we go to the lower half to our left. The middle value will be the Q1. Then upper half, which will be on the right side of the middle value. The middle again will give us the Q3. So to find the interquartile, we know the Q3, we know the Q1, the difference will give us. So for example, here they told us to find the interquartile range of the test scores. So we know the Q1 is 10, Q2 was 15, Q3 was 18. So to find the interquartile, it will be 18 minus 10, which will give us 8. Next, how do we plot the Box-and-Whisker plot? In order to plot the Box-and-Whisker plot, we need 5 values. We need the minimum value of the data set. We need the maximum value of the data set. Then we need the Q1, Q2, and Q3. So here we say the highlight important features of a data set. So the Box-and-Whisker plot will tell us the maximum value, the minimum value, the first Q1, 1/4 of it, half Q2, 3/4, again Q3. So those are the value, the 5 number summary. We find the minimum entry, Q1, Q2, Q3, and the maximum. Now, from our previous example, we can again get the Box-and-Whisker plot, because from the data set, the minimum was 5, the maximum was 37. We were able to get the Q1, Q2, and Q3. So that's the steps here. First, we find the 5 number summary of the data set. Again, that's the minimum, maximum, Q1, Q2, and Q3. Then we construct an horizontal scale that will span the range of the data. Then we plot the 5 numbers above the horizontal scale. So we can see our example here. This is our horizontal scale. We have the minimum entry, the maximum value on the right side, and then the Q1, Q2, and Q3. Now, when we get the Q1, Q2, Q3, this is where we are going to plot the box. So we plot the 5 numbers. Then next we draw a box above the horizontal scale from Q1 to Q3, Q1 to Q3. Then we draw a vertical line where we have the Q2. And that will be, again, our Box-and-Whisker plot. So from the Box-and-Whisker plot, we can tell the minimum value, the maximum value, and the Q1, Q2, and Q3 to visualize the data. So we have an example here. They say we should draw a Box-and-Whisker plot. And here they give us the minimum value to be 5. The Q1 is 10. Q2 is 15. Q3 is 18. And the maximum value is 37. This is the same as the first example, the test score of the 15 employees. So we can plot again a horizontal line. We get our 5, we get our 37, then 10, 15, and 18. Then we draw our box from Q1 to Q3. Then we put a vertical line on the Q2. Next week, talk about the concept of percentile and other fractals. So we know quartiles means we divide the data into 4 equal parts. Now, deciles means we are going to divide the data into 10 equal parts. So for example, from D1 up to D10. Normally, we don't mention the last 10 because last 10 means all the data. So we go from D1 to D9. Percentile means, again, we divide the data into 100 equal parts. So it will go from P1 to P99. So we have example here. This example is about OGAF, which represent the cumulative frequency distribution for SAT test score for college-bound students in a recent year. What test score represent the 72nd percentile, and how should you interpret this? So from the data set here, we can see our 100 percentile and the test score somewhere around 2400. Somewhere around 60 percentile, we have test score maybe around 1500. So here we say the 72nd percentile correspond to a test score of 1700. So we have our red line, broken line, 72nd percentile. So where we meet the graph, then we go down. and that's 1,700. So this means that 72% of the students had an SAT score of 1,700 or less, because it will be 1,700 to the left or less. Next, we are going to learn how to find the standard score, which we normally call the Z-score. So normally the Z-score represents the number of standard deviations a given value X fall from the mean. So that's why the Z-score formula is always X minus the mean divided by the standard deviation. So the Z-score will give us the value we are looking for minus the mean over the standard deviation. So it will be X minus mu over standard deviation. So let's see an example here. Here we have in 2007, Forrest Whitaker won the Best Actor Oscar at age 45 for his role in the movie The Last King of Scotland. Also, Ellen Mirren won the Best Actress Oscar at the age of 61 for a role in The Queen. Now, the mean age of all the Best Actor winners is 43.7, and the standard deviation is 8.8. Now, the mean age of all the Best Actress winners is 36, with a standard deviation of 11.5. Now, we want to find the Z-score that corresponds to the age for each actor and actress. Then we compare their results. So here we know Forrest Whitaker is an actor, and we find out that Forrest Whitaker age is 45. The average age for all the actors is 43.7, and the standard deviation is 8.8. So the Z-score gives us 0.15. This means 0.15 standard deviation above the mean. Now with Ellen Mirren, age is 61, and the average age for all the actresses is 36. The standard deviation was 11.5. So this gives us 2.17 standard deviation above the mean. Now the question says we should compare the two. That's for the actors and also for the actress, for both Whitaker and Ellen. Now here we say the Z-score corresponding to the age of Ellen Mirren is more than 2 standard deviation from the mean. So it is considered unusual. Now, compared to the other Best Actress winners, she's relatively older, because we can see since the standard deviation were twice, we can say that she's older because the value is far greater than the mean. Now, with Forrest Whitaker, it's only slightly higher than average age of the actors. So 0.15 is almost close to the mean. And so here we are trying to say that the higher the Z-score means the value that we are looking for compared to the Z-score is greater than the mean or far from the mean. That's the whole concept here. So in these lectures, again, we went through the concept of quartiles of a data set. As we said earlier, the quartiles of the data set means the data set is divided into 4 equal parts. We're normally going to find a Q1, Q2, and Q3. In order to find these quartiles, first of all, we need to put our data in ascending order, increasing order. We need to sort it. Then from there, we find the middle value of the whole data set, and that will be the Q2, which is the same as a median. We go to the lower half side to the left of the Q2, and we can find the center, and we get the Q1. We go to the right side, which is the upper half. We find the center value, and that will give us Q3. Normally, Q3 will be 75% of the value, either is equal or less, equal to Q3 value or less. From there, we'll also learn how to create a Box-and-Whisker plot, and we say we need a 5 data set, data, for example, the minimum value, the maximum value, the Q1, Q2, and Q3, and we can come up with the Box-and-Whisker plot. We also understand the concept of fractals, such as also with the percentiles, 100%. Decile means we divide into 10. Percentile means we divide into 100. Quartile means we divide into, again, 4. Then we also learn how to find the z-score, which is always the value minus the mean divided by the standard deviation. The higher the z-score value means, and the value is way greater than the average of the values. So again, wish you the best and see you in the next lectures.